You've seen the pictures, right? The first steps on the moon? It's iconic. But here's something you probably don't know. Just minutes, literally minutes before that historic moment, the entire Apollo 11 mission was this close to total disaster. So let's get into it. This is the story of the crisis that almost scrubbed the landing, and, more importantly, the woman in mission control whose genius saved the whole thing.
All right, to really get what happened, you have to imagine yourself right there, inside the lunar module. We're talking about the most critical moment of the entire mission. The tension? You could cut it with a knife.
Okay, so the date is July 20th, 1969. You've got Neil Armstrong and Buzz Aldrin inside the Eagle, the lunar lander. And they are descending, fast. That gray, pockmarked lunar surface is just rushing up to meet them.
They are just 3 minutes. Think about that. 3 minutes from making history. This is the final descent, the absolute most dangerous part of a journey that's taken them almost 250,000 miles from Earth.
And then, out of nowhere, a piercing alarm just shatters the concentration. A yellow light starts flashing on the console. The code? 1202. And you can bet the astronauts' hearts just dropped. Because that alarm means one thing, and it's not good. The guidance computer, the literal brain of the lander, is overloaded. It's about to crash.
And if that computer fails, the landing is over. It's that simple. Back in Houston, mission control goes dead silent. Every single screen is flashing that same terrifying error. And for one person in that room, the lead software engineer, Margaret Hamilton, well, this is it. This is the moment everything she's worked for gets put to the ultimate test.
So who was Margaret Hamilton anyway? I mean, how did she end up here, with the weight of the entire moon mission basically on her shoulders? Her story, her path to this exact moment was, well, it was as brilliant as it was unconventional.
And what's so fascinating is her background, right? She didn't even study computing. Her degree was in mathematics and philosophy, which, when you think about it, gave her this incredible foundation in pure, hardcore logic. She cut her teeth programming weather prediction systems, then moved on to these huge Sage air defense computers. So when she heard MIT was hiring for Project Apollo, she jumped on it. And get this, she was the very first programmer they hired.
And the challenge NASA handed her lab at MIT, it was just monumental. You have to remember, back in the 60s, computers were these massive, room-filling machines that were notoriously buggy. NASA needed one that was basically foolproof, 100% reliable. Oh, and it had to fit into a tiny box just 1 cubic foot in size. No big deal, right?
Hamilton knew, with actual human lives on the line, that the software couldn't just work. It had to be bulletproof. It needed a way to deal with the unexpected, to basically save itself if something went wrong. And that realization, that led her and her team to create something genuinely revolutionary.
Okay, so they built the software around this idea called asynchronous processing. Now, back then, computers were pretty dumb. They can only do one thing at a time, in a perfectly straight line, like a checklist. Hamilton's big idea was to teach the computer how to juggle, how to handle multiple tasks at once, and crucially, how to know which of those tasks were the most important.
So here's the genius of it. Her team assigned a priority level to every single job the computer might have to do. Think of it like a to-do list, but with must-do and nice-to-do items. If the computer ever got overloaded with tasks, it was programmed to instantly drop all the nice-to-do stuff, the fluff, and pour every ounce of its processing power into the must-do jobs. Like landing the spaceship safely.
This was a complete game changer. The old way of doing things was brittle. One little error, one unexpected hiccup, and the whole system could just crash. Game over. But Hamilton's new system was resilient. It was actually designed with the expectation that things would go wrong. It was built to handle errors, to recover from them. It was built to survive.
Which brings us right back to the Eagle. It's just minutes from landing on the moon. That 1202 alarm is screaming. This was it, the moment of truth, the ultimate test of Hamilton's system. Would this resilient design actually work in the real world under the most extreme pressure you can possibly imagine?
So, what was causing this massive overload? You're not going to believe it.
It was a simple mistake. Buzz Aldrin had accidentally flipped a switch for the rendezvous radar. Now, that system was only meant for the trip back to orbit. It was totally useless for landing. But it was flooding the little computer with junk data, eating up about 15% of its brain power.
Just as Margaret Hamilton herself put it, the software was smart. It was smart enough to know that it was being asked to do way more work than it was supposed to. It knew something was off. But instead of just giving up and crashing, it did exactly what it was built to do.
And bam, just like that, the software went to work. First, it threw up the alarm to let the crew and mission control know, hey, we've got a problem here. Then, it automatically dropped the lowest priority task, which happened to be processing all that useless radar data, and immediately refocused all its power on the critical jobs needed for landing. It's just incredible. It fixed the problem all by itself.
And because Hamilton's software had already diagnosed the problem, flagged it as non-critical, and started the recovery process, the flight director back in Houston could make the call. He could confidently give the one command everyone was holding their breath for. Go. The landing was on. It was this perfect, beautiful dance between the astronauts, mission control, and one seriously smart piece of software.
So the moon landing was a success. Neil Armstrong took his one small step. But Margaret Hamilton's story, her impact, it didn't just stop there on the lunar surface. The principles she created, the ideas she fought for, they would go on to change pretty much everything.
See, she fought to have programming treated not like some kind of quirky art form, but as a real, formal discipline. And to give it a name, she coined a term that we all use today, software engineering. Her argument was simple. Building software, especially software that people's lives depend on, should have the same discipline and rigor as building a bridge or an airplane.
And it's wild to think about now, but at first people actually laughed at her. They mocked the very idea of software engineering, thought it was a joke. But you know what? After the Apollo 11 computer handled a mission-critical failure flawlessly in front of the entire world, nobody was laughing anymore. Her vision was proven right on the biggest stage imaginable.
So here's the real takeaway. Those systems that Hamilton pioneered, the ones that can prioritize tasks, self-correct, and handle errors on the fly, they're everywhere today. They're running the phone in your pocket, the car you drive, the entire global banking system, the planes we fly in. So the next time you use pretty much any piece of modern tech, think about this. What part of your world is only working, is only this reliable, because a woman named Margaret Hamilton taught a computer how to save itself?